So what are some of the more specific functions that our DNS server performs? Well, let's take a look. So our DNS server, as we mentioned, performs resolution. Now, our resolution goes two ways. It goes fully qualified domain name to our IP address, and these are known as forward lookups. And then we have IP address to fully qualified domain name, reverse lookups. Forward lookups are our typical lookups when we type in www.cyber.it, and it goes to our DNS server. Our DNS server goes to our internet DNS server, and then that DNS server says, okay, that address is at this IP address. Reverse lookups are if we typed in, oh, what is this IP address? What's its server name? And then we'll go out to that DNS server, and it'll check its records and see if it has a reverse record, pointer record, and see if it can find its IP address from the fully qualified domain name. So our resolution occurs at using our fully qualified domain names starting at our top level domains. Now our top level domains, as we talked about a little earlier, include things like .com, .edu, .gov, .mil, .org, and so on and so on. .org, not .ord. So on and so on. And these are read right to left. So if you wanted to go to portal.microsoft.com, our DNS server doesn't read your request from left to right. It needs to start from right to left. So you may see website addresses that look like this: http://www.portal.microsoft.com/login. So let's take a look at this and see if we can get rid of some of the extra stuff. So http www.portal.microsoft.com/login. Well, immediately we can remove this / or actually let's start from this side. The http :/ is just telling our computer which protocol to use. We're going to use HTTP protocol in order to connect to this website, because HTTP is what's going to let us connect to a website, let us pull information from a website. So that's not part of our DNS query. That's just part of our computer specifying which protocol it's going to use. So that's not part of our DNS query. www is the start of our DNS query, but our www means that we are asking the server to give us its World Wide Web page. That's why a lot of times you can just type in portal.microsoft.com, and then our browser will fill in the rest, because it's assuming that we're going to want to go to the World Wide Web page on this server. So, or our www server, whichever we have configured. So we're telling our computer, yeah, we want to go to the www server, the World Wide Web server. So www.portal.microsoft.com, the rest of this is part of our query as well, because that's part of our domain. Microsoft, part of our domain. .com is our root domain. And then what about this / login? Well, that / login is also not part of our DNS query, because that / login is simply asking for an additional subfolder or subfile on this web server. So if you think about a file path, if you're going to a certain file on your computer, you'll see something like C / or you'll see / C / users / administrator / desktop. So we're essentially going to this server and saying, I want to go to your main web server / your login page. So that's not part of our DNS query. Our DNS query just wants to find the IP address of this server, the www.portal.microsoft.com server. So we're going to start from right to left of this as we're resolving. So this was just us dissecting it. So our computer is going to say our initial internal DNS server is going to say, okay, I don't know where this query is, so I'm going to send it up to the next level DNS. Now, our next level DNS on our internet is going to say, okay, I need to find the server who knows who has the authority to tell me information about the .com domain. So it says, okay, I know which DNS server is allowed to tell me about the .com DNS, or the .com domain. And then we need to know who can tell us about the .microsoft subdomain. So our .com domain is our root domain that is encompassing of all of our websites and servers that are something.com. So we find the one that can tell us information about that. Then we say, okay, now where is the next level up, the .microsoft domain? And we say, okay, here it is. Now where is the Microsoft, or the portal.microsoft domain? So then we find that. And then once we're there, once we're at whichever server can tell us about the portal.microsoft.com domain, we say, okay, now where's your web server? Where's your www server? And then it gives us the IP address, and then now our computer sends an HTTP packet to that IP address requesting its login page. So that's how our URL will translate into our DNS request. Now, our DNS servers can provide us with dynamic DNS. Now, dynamic DNS versus a static would be a auto-updating of our records. Our DNS records are going to be the information inside of our DNS servers that's configured with what goes where. The information to allow us to resolve fully qualified domain names to our IP addresses, and the reverse. Our dynamic DNS will automatically update those records, so we don't have to manually change things. And our dynamic DNS will monitor changes in connection with DHCP. So DHCP hands out a lease to a particular server or a particular computer. It lets our DNS know, and our DNS will update those records. Now, in our domain environment, we don't necessarily want all the computers that connect to our domain to be able to allow them to update DNS for the computers. Well, why not? Why don't we want to allow our client computers the ability to update DNS? Well, if we give that ability to every single client computer, we may have a client computer that says, oh, hey, DNS, by the way, I want you to add this record in here. I want you to add in here that www.facebook.com points back to me. So if that record is maliciously added, then someone could stand up a little client computer with a fake web server on it, and then when we add that record and our DNS says, oh, you requested www.facebook.com, here's its IP address, sends us to the client computer that has a completely constructed fake lookalike of facebook.com. You enter in your username and password and the URL bar says www.facebook.com. It looks completely fine, but then your information is being transmitted to that computer that you actually connected to. So our DNS server, once it tells us, oh yeah, this IP address is facebook.com, our computer will say, okay, well, I'll go there. And then our URL bar will display that we're connected to facebook.com, because that's what our DNS told us that we're connected to. It's not going to connect the IP address. It's not going to show the IP address of the server that we're connected to on our standard browser URL bar. It's just going to show what address it thinks it's connected to. That's why it's important to keep our DNS secure and keep our DNS from being updated maliciously.